Hi everyone! Welcome to our Scientastic class. I'm teacher Bridgeline and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together. Let's have a short review. The flow of electrons in a material such as wire is known as current or capital letter I. The driving force or the electrical pressure behind the current to flow is known as voltage or capital letter V. And the property of the material that limits the current flow is known as resistance or capital letter R. The relationship between current, voltage, and resistance is expressed in Ohm's law. George Simon Ohm discovered this law. So what is the relationship between current and voltage? If you increase the voltage, the current will also increase. If you decrease the voltage, the current also decrease. So the relationship, current is directly proportional to voltage. In symbol, I is directly proportional to V. How about current and resistance? If you increase the resistance, the current will decrease. But if you decrease the resistance, the current will increase. So the relationship, current is inversely proportional to resistance, or in symbol, I is inversely proportional to R. This relationship is expressed in Ohm's law. This states that the current flowing in a circuit is directly proportional to the applied voltage and inversely proportional to the resistance of the circuit, provided that the temperature remains constant. Our equation is I equals V over R, wherein I is the current, V voltage, and R is the resistance.
Ohm's law is usually written as V equals I times R. But what if we wanted to solve for voltage or resistance instead? One way to easily memorize this, use a triangle formula. First, draw a triangle shape, then divide it like this. Write V on top of it and I and R at the bottom. Our formula for voltage is V equals I times R. For current, I equals V divided by R. And for resistance, R equals V divided by I. Depending on the values given, the formula can be used to calculate voltage, current, and resistance in a circuit. Let's have a sample problem. If you have a filament bulb and it has a current of 30 amps running through it with a potential difference of 120 volts across it, what is the resistance of the bulb? Our given 30 ampere is the current and 120 volts is the voltage. We are required to find the resistance of the bulb. Our equation, R equals V over I. For our solution, we are going to substitute voltage into 120 volts and current to 30 amps. Our answer, R equals 4 ohms. The resistance of the bulb is 4 ohms. A diode has a current of 5 amps running through it and a resistance of 5 ohms. What is the potential difference across the diode? For our given, 5 amps is the current and 5 ohms is the resistance. We are required to find the potential difference or the voltage. Our equation, V equals I times R. For our solution, substitute I to 5A times R, 5 ohms. 5 times 5 equals 25. Our answer, V equals 25 volts. The potential difference across the diode is 25 volts. A coffee cup immersion heater utilizes a heating coil with a resistance of 8.5 ohms. Determine the current through the coil when operated at 110 volts. For our given, 5 ohms resistance and 110 volts voltage, we are required to find the current. Our equation, I equals V over R. For our solution, substitute V to 110 volts and R to 8.5 ohms. Our answer, I equals 13 ampere. The current through the coil when operated at 110 volts is 13 ampere.
Did you know that our body is controlled by electrical impulses from brain or other organ? A small area within the heart known as sinoatrial node controls its beating.
Sometimes, the rhythm of the heart can be disrupted, beating too quickly or in uncontrolled way. This can lead to death if a normal rhythm isn't established quickly. A defibrillator can use to shock the heart into re-establishing a normal rhythm. Unsynchronized current flows from the defibrillator into the heart, causing it to momentarily stop beating. It can then restart with a more controlled rhythm.
This is all for today, class. See you on our next episode. Bye!